Hello everybody, this is Rudra Pradhan here. Welcome you all to BMD lecture series. Today we will continue with the predictive analytics, and that too the discussion is on diagnostic of regression modeling. So, the typical coverage is on three topics, that is with respect to multicollinearity problem, autocorrelation problem and heteroscedasticity problems. In fact, we have solved couple of problems earlier, that too highlighting the case of bivariate analysis and the case of multivariate analysis, and the objective behind this particular structure is to predict the dependent variable with respect to independent variables. Now, while doing all these things, there are certain issues we like to address before you do the kind of prediction, and these issues are typically highlighted here. And in fact, so far as a diagnostic is concerned, we have many things we are supposed to check, and here we specifically focus on three things, that is the multicollinearity issue, autocorrelation issue and heteroscedasticity issue. While multicollinearity is a multivariate problem, in the case of autocorrelation and heteroscedasticity, it can be a bivariate problem and it can be also multivariate problem. So, in the case of multicollinearity, it is the game with respect to independent variables, and in the case of autocorrelation and heteroscedasticity, it is the game with respect to error terms. However, all these three components are treated as virus in the regression setup, and that too in the predictive analytics. So, what is required actually? So, we have to first address all these problems. You have to check thoroughly and make ensure that the particular model is free from multicollinearity, autocorrelation and heteroscedasticity before you go for the prediction. So, what is exactly the multicollinearity, autocorrelation and heteroscedasticity, how to detect and how to solve. So, these are the kind of discussions we can cover today. So, let us start with a simple problem here, and here the problem is with respect to dependent variable and 5 independent variables. So, that means technically the objective behind this problem is to predict y with respect to 5 independent variables. Now, when we will go for model building or the kind of model design, so we have actually plenty of options. So, these options are first case with respect to single predictor, and with respect to 2 predictor, and with respect to 3 predictor. So, now technically, so this is with respect to single predictor and this is with respect to 2 predictors, this is 3 predictors, 4 predictors and 5 predictors. When there is a question of multicollinearity, then in the case of single predictor, this will not be the game, but it is the case for the predictor 2 predictor case, 3 predictor case and 4 predictors case, and also 5 predictors case. So, altogether we have now plenty of models. So, the idea is which model will be the will be considered as the best so far as the prediction is concerned. So, now typically our objective is here to predict the y with respect to 5 independent variables, but technically after the diagnostic process, there may be chance that y can be predicted with only 1 variable or 2 variables or 3 variables, or it can be 4 or it can be with 5. We have no idea, but over the time we can actually explore these issues. Then finally, we have to fix which one is the best for our prediction. So, that means technically we have here plenty of options, and all these options cannot be simultaneously considered. So, only one option can be simultaneously considered, and how to find out the particular model is useful for these predictions, we can go ahead with the kind of discussions. So, what we are supposed to do here, that we have to find out which particular model is the best for this prediction. So, we have to go for the kind of search process, and one of these search process or mechanism we like to follow is the multicollinearity issue. So, now the question is what is exactly multicollinearity? As I have already pointed out, multicollinearity is a game of multivariate analysis, and in the simple language. So, multicollinearity represents the existence of linear relationship among the regressor. Technically, simply you can calculate through correlation structure. So, that means technically correlation among the regressor should not be equal to 0. If it is exactly equal to 0, then there is no multicollinearity. So, that means if there is actually they are not equal to 0. So, then there is a multicollinearity. So, technically, so we have two options. In the first case, correlation among the regressors equal to 0. So, where the declaration is no multicollinearity, and correlation among the regressors not equal to 0, then there is a multicollinearity. Now, in this case, so that means if the first case occurs, so that means the model is free from multicollinearity, then model is good for the prediction. But in the case of the second case, where correlation coefficient between x and x I and x j not equal to 0. So, it may have two different options. In one options it may be equal to correlation coefficient equal to 1, and in another case correlation coefficient may be less than 1. So, that means, so there is a third option which is equal to 0, where we have already declared that there is no multicollinearity. So, now when there is a r equal to 1, that means correlation among the regressor equal to 1, then it is called as it is a question of perfect multicollinearity, and in this case model cannot be used for any kind of prediction. But in the case of less than 1, so it depends upon what is the degree of correlation, that is called as imperfect multicollinearity. But if the correlation coefficient close to 1 means, so the degree of problem will be very high. When it will be close to 0, the degree of problem will be very low. But whatever may be the case, so we like to find out what is the exact nature or the degree of multicollinearity, then we will try to solve these problems as per the model requirement. So, let us see how is this particular structure. So, in the first instance the look will be like this. So, this is the case where r equal to 0, this is the case where r equal to 0, and here r will be not exactly equal to 1, but it will be approximately close to 1. So, so it is the movement of no multicollinearity to low multicollinearity, then slightly increasing towards high multicollinearity. So, that means it gives the signal that the problem is going to dangerous. So, we try to minimize the particular process. So, that means technically our search process will be from this angle to this angle. So, this is how we are looking for the kind of search process. So, how we have to do that? So, we can actually get to know in this particular process. So, let us see the kind of game here, and there are many different ways actually you can check the multicollinearity. So, the first approach is simply called as correlation approach. So, you can prepare the correlation matrix and try to see whether the correlation coefficient coefficients are very high, and if they are high and statistically significant. So, how you have to sort out the particular problem. Besides, there are many other issues or the tricks through which you can actually detect the multicollinearity, like the conditioning index, the VIF factors, and through partial correlation coefficient and multiple correlation coefficient, and through auxiliary regression. So, many ways we can actually check the multicollinearity. But by the way, if there is a multicollinearity, so you follow any methods, it will be showing the kind of multicollinearity problem. So, now we think we try to find out what should be the particular structure or the degree, and then we like to sort out the solution. And so far as a solution is concerned, so these are the following mechanisms usually you follow. In fact, there are standard solutions are there, alternative structure are there to increase the sample size, to drop the collinear variables, use different mechanisms. But here it is the standard structures without changing sample size, without dropping any variables or something like that. So, we have to see the formal structure through which you have to find out a particular model which is free from multicollinearity. So, in order in order to justify this, so we start with a simple problem, and then we check how is the multicollinearity and how to sort out this particular problem. So, in this context, so the problem is with respect to here 5 variables: expenditure on clothing, that is the dependent variables, and followed by independent variables are disposable income, liquid assets, price index for clothing, and producer price index. So, now what we is supposed to do? So, let us go to this spreadsheet, and this is what the data all about, and what will we do here? So, we have actually following data set, and we like to check whether there is a kind of multicollinearity or not. So, the first hand check is to find out the correlation matrix among the regressors. So, that means the regressors are here, these are the regressors, and through which you have to check the kind of position. So, what will you do? So, go to the data analysis package, and then you find out to correlation structures, give the indication about the correlation, and then we will highlight the variable indications, all these independent variables, that is the 4 independent variables, and it will give you the kind of output matrix. So, this is actually correlation matrix. Here the correlation matrix gives x 1 to x 2, x 1 to x 3, x 1 to x 4, and x 2 x 3, x 2 x 4, similarly x 3 and x 4. But in all the cases we find there is a high correlation. So, that means it is clear cut signal that there is a problem of multicollinearity. So, so in the first instance, before you start the kind of prediction, so this gives some kind of negative signal. And again, so what will you do? That will be checked through regression analysis. So, again you go to the you go to this kind of data analysis package, because our basic objective of this problem is to predict the expenditure on clothing subject to disposable income, liquidity assets, price index of clothing, and general price index. So, then what will you do? So, you have to choose a regression package, and then we have to start working on this. So, the dependent variable is by default expenditure on clothing, and the independent variables will start from disposable income to general price index. So, then we will find this is actually the complete regression output. Here what is happening actually? So, if you these are all 4 variables, and these are all t statistics. So, now you will find some variables are statistically significant and some variables are not statistically significant. For instance, so this is actually x 2. So, it is statistically significant at 1%, followed by x 3 and x 4, and x 3 is having low impact compared to x 4. So, that means technically one variable is not statistically significant, and in the contrary r square is very high, but what is required here? So, if there is a high r square close to 1, then most of the variables should be statistically significant, but here it is not the case. So, that means it is the clear cut signal of multicollinearity. So, that means the full model may not be actually work here. So, out of 4 variables, at least 4 variables, it means few less than 4 variables can be the right solution to go for this prediction. So, which 3 or which 2 variables are right choice, that we have to go for this particular process. So, there are 3 mechanisms. So, if you go to any software there is a stepwise option. So, if you give the option to stepwise, so by default it will give you the exact variables combinations through which you can do the prediction, and that too it is free from multicollinearity. Otherwise, you can go by a forward search process and backward search process. In the forward search process, the most important variable should enter first. So, that means technically, so we can start with like this, we can start with first y with the second variables, that is here the first independent variables, and then followed by last variables, and then second last, and then finally this one. So, that means technically if you go to this particular matrix here. So, what will you do here the process? So, here so the first model will be y with respect to the first disposable income. So, this is a disposable income. So, then you have to check actually, let us say this is beta 1 coefficients and followed by r squares and f statistics, and again in the second models. So, what will you do, y equal to function of disposable income with the liquid assets, then here the coefficient will be beta 1 and beta 2, then r squares and f like this. So, now one after another variables you have to enter to the systems, and every time you have to check actually whether the variables are significant and the model fitness are okay as per the requirement. So, now this is the first model. Now, you have to go for the second model. If the second model improves the first one, then you can reject the first one and opt the second one. So, now second one is the good fit for the prediction. Again, so you allow another variable and you check whether the variables are statistically significant, r square is improving, f is improving, then you continuously go ahead with this kind of structure. Then you have to stop at a particular point of time where the new entry of any particular variables will not improve the significance level and will not improve the r square and adjusted r square. So, this is this search process through which you have to check the multicollinearity and to find out the solution for the prediction requirement. Now, the second structure of this particular problem is with respect to second structure is with respect to autocorrelation problem, and for that okay. So, the second problem is with respect to autocorrelation, and this is actually with respect to error term. So, like the previous one, so here we like to try covariance between two error terms. If the covariance between two error term is coming 0, so then the declaration is there is no autocorrelations. However, if the covariance between two error term is not coming equal to 0, so then it is actually autocorrelation. That means, technically like the multicollinearity case. So, where we are correlating x 1 upon x 2 or x 1 upon x 3. So, here u 1 upon u 2 or u 1 upon u 3 like this. So, that means, in this case, so we have no correlation means autocorrelation, but in this case there is a autocorrelations. So, it like multicollinearity, it is also a kind of virus that need to be actually detected, and then finally, we look for the solution. So, what is the procedure here? First estimate the model, get the error term, and then you connect with the error one particular error term with another error term and check whether there is a correlation among these error clusters. If there is a correlation, what is the degree of this correlation? If it is high, then it is again problem, and that particular model cannot be used for prediction. So, like multicollinearity, we have to find out the particular the degree of the autocorrelation and the kind of solutions. Let us see how we have to work out on this, and in this context. So, the procedure actually you can understand this is a simple multivariate model, and in order to understand autocorrelation. So, you have to create a autocorrelation first order autocorrelation structure. So, u t upon rho u t minus 1, and technically rho is called as autocorrelation coefficient. So, that means, the technical term is here, error term depends upon the past error term, that is the lag of 1 year, and we are assuming that today's error term depends upon yesterday's error terms. It may not there, but we have to check and find out whether there is a possibility or not. If it is a possibility, what is the kind of degree. So, likewise so the kind of structure will be rho is the autocorrelation coefficient. It like correlation coefficient. So, the value will be either 0 or plus minus 1. So, if it is 0, then there is no autocorrelation. So, this is the case, and if there is a autocorrelations, then p equal to either positive rho either positive value or rho equal may be negative value. It may plus 1, it may be minus 1. If it is plus 1, then positive autocorrelation. If it is minus 1, it is the negative autocorrelation. So, now what will we do here? So, we like to check what is the actual structure through which you have to check the particular item. So, these are all second order, third order and pth order of autocorrelation issues. So, that means the a error term of a particular year depends upon error term of previous years. Previous years means 1 lakh, 2 lakh, 3 lakh and so on. So, it is a kind of chain, it is technically called as a auto regressive scheme, and we like to check, we like to see whether the particular error term is connected with the previous error terms. If there is a strong correlation, then that is actually very danger and for the kind of prediction. So, we like to find out what is the degree of such relationship. So, technically there are many mechanisms through which you can check the process. So, either graphically you can plot the error term and get to know the kind of nature, or else there are formal tests are there through which you can check. So, one of the fantastic test is called as Durbin-Watson D statistics and BG test, Durbin's H statistics and Engel's Arch test. But most of the softwares gives the value of Durbin-Watson D statistics, and through the value of Durbin-Watson D statistic you can get to know what is the position of this autocorrelation. That means technically what is the exact degree through which we go for the kind of predictions. So, what will we do here? So, I will just highlight the Durbin-Watson statistics and then let you know how is the particular structure. Durbin-Watson D statistics, the structure will be generally like this. So, it depends upon the covariance between two error terms. So, that means technically this one. So, this is the rho coefficient, that is autocorrelation. So, that means technically Durbin-Watson D statistic will be covariance between ut minus 1 by variance of ut. So, that is how we have actually reported here. So, this is how the Durbin-Watson D statistics value. So, this gives the kind of procedure through which you have to calculate, and then we have to check the degree of existence. Generally the Durbin-Watson D statistic D equal to 2 into 1 minus rho, and rho is the autocorrelation coefficient. So, that is actually covariance of ut upon ut minus 1 divided by variance of ut, and when rho equal to 0, then D equal to 2, that is where rho equal to 0. When D equal to 4, then in that case rho equal to minus 1, and when D equal to 0, where rho equal to exactly 1. So, these are the 4 extremes, and in the case of D equal to 2, where rho equal to 0, that is actually free from autocorrelation. Otherwise, the range will be vary from 0 to 4, but actually what is the optimum range through which you can do the prediction. So, usually we can see if the Durbin-Watson D statistic will be ranging between 1.5 to 2.5, then this is a tolerance through which you can actually go ahead with the prediction. Otherwise, perfect structure is where D equal to 2, but it is very rare to get this particular situation, but we try to find out what is the best possible way through which you have to manage the kind of predictions, right. So, what I will do? So, I will take you to this take you to a particular problem, and then check you how it can be actually connected with autocorrelation. Let us have an examples. I have taken two variables here, imports data and GNP data, and then you go to this spreadsheet, and this is actually the kind of import the data structure. So, here imports data and GNP is there. So, we are trying to estimate the imports. So, what will you do technically? So, you go to the data analysis, first you go to the regressions, then highlight the import structure here. So, ranging from this data to this data, then again you give the independent variable declarations, that is the GNP from this particular data point to this data point. So, you will get first and regression output, and first and regression output, that is actually from this. Okay. All right. Now, this is what the regression output. So, now so intercept is this much minus 2461.4, and the beta coefficient is 0.28. By using this particular regression output, so what will you do? So, we first actually get the import estimated equation. So, this is import estimated equation, just put alpha value and beta value, and then you scroll this structure. So, you will get the entire spreadsheet. So, that is actually estimated imports, and this is the actual import, and the difference between actual import and expected imports will give you the error component. And now, after getting the errors, so you will find out the E t minus E t minus 1, that is the difference between two different and error two different situations error coverage, that is actually like U t and U t minus 1. So, here this is E t, and then the previous data points will be E t minus 1. So, the difference will be represented by E t minus 1. So, these are the difference between E t minus 1, and we need actually square of this variance of this particular structure. So, squaring this side, so we will have the entire series like this, and then finally we will get the sum of this particular error variance, and then finally we will get error sum squares, that is square root of squaring the error sum squares. So, we will get the particular items. So, now the as per the Durbin-Watson D statistics, so the covariance of U t minus 1 by variance of U t will give you this particular results. So, as a result, so this value by this value will give you the error component, means the particular Durbin-Watson D component. So, as a result, so this particular value will give you the degree of multicollinearity, but in this context, so the multicollinearity value is coming 0.95, which is actually not good for the model predictions. So, what will you do again? So, to solve these problems, you have to increase the data points, or you have to go for data transformations, or you can add some variables, or you can actually change the functional form. So, somehow the Durbin-Watson D statistics should improve. So, it should be coming in between the range of 1.2 or 2.5. So, that we can go ahead with these predictions. So, now that means technically we get to know how Durbin-Watson statistic can be calculated, and what should be the exact range through which actually prediction feasible or not. So, typically if the Durbin-Watson statistic range is coming 1.2 to 2.5, so then we will go ahead with the predictions. If it is not coming within that range, so whether it is a lower range or upper range, then we need to do the kind of restructuring about the entire modeling process, either change the functional form, increase the sample size, go for the data transformations in some extent, then again re-estimate the model and find out the error term, again calculate the Durbin-Watson D statistic, and finally check the value. Obviously, after doing all these process, the value of the Durbin-Watson statistic will improve, and some of the software will directly give the kind of value. So, what you will do? You have to just operate the process, then every time you rerun the model, and then you will check the Durbin-Watson statistics. So, you will continue to this particular process till you get the model which is free from autocorrelations. So, this is actually another virus through which you can move the particular model diagnostics, and this third one is the heteroscedasticity. Heteroscedasticity is a case where error variance is not actually homogeneous, but we have already earlier in discussion that error variance should be same throughout the kind of models. But if that is not the case, then this will give you the case called as heteroscedasticity. That means technically variance of error term is not equal to constant, that sigma square, then it is a question of heteroscedasticity. So, that is the case here heteroscedasticity. So, that means if it is same, then it is a homoscedasticity. If it is not same, then it will create a structure called as heteroscedasticity. So, now again like multicollinearity and autocorrelations, here we have to check actually the structure of heteroscedasticity, and then we try to solve the problem of heteroscedasticity before we go for the predictions. So, what we will technically do here? So, again so you have to go to check process, and then find out whether there is a kind of heteroscedasticity or not. So, generally we have here two options, one option is homoscedasticity and heteroscedasticity. So, the graphically homoscedasticity means you see the curve structure, it is actually coming actually similar kind of length and homogeneous variance altogether, but in other contrary in the other case here the degree of movement is changing. So, this is what the signal of heteroscedasticity. This is a graphical inspections, but we have actually different mechanisms through which you can check the heteroscedasticity. So, means like autocorrelation case here also we can graphically check that is what we have already seen, and then the graphical check means you just have the error term which is the difference between actual value and the estimated value, and then plot these error terms. If it will show a kind of trend, then this gives the signal that there is a heteroscedasticity problem. In the meantime, there are lots of formal tests through which you can check the heteroscedasticity, like BPG test, Parg test, Goldflat test, White test, Harvest test. So many tests are there through which you can actually check the heteroscedasticity and find out whether there is a problem or not. If there is a problem, you try to solve this problem before you do the prediction, otherwise your prediction will not be perfect as per the management requirement. So, technically what I will do, I will take a problem again, then I will highlight how we can actually check and go for the kind of heteroscedasticity issue. So, what will you do? We can take another problem. So, this is actually problem with respect to saving and income, and again, so the first check of the process is go to the data analysis and then choose the regression package. So, here in this particular problem, so we are allowing saving is a dependent variable, and it is typically depends upon income, and then accordingly here we will specify again income as the independent variables, and then what will it do? So, we will just allow to run the model, and after getting the estimated models we will find. So, the saving and income are positively related to each other, and the alpha intercept is coming 1109 and beta intercept is coming 0.004. So, this gives the estimated structure. So, what will you do? So, you go to the actually here. So, find out to saving estimates that is equal to here the model outcome is here the model outcome is 11 10 and 004. So, what will you do? We will put here 11 10 okay, plus 0.004 into income. So, then you enter and then you scroll again. So, this will generate the saving estimates. So, this is you can get the saving estimates. Then finally, what will you do? Find out the error term. So, this is actually error observation. So, error observation will be the actual savings minus the estimated savings, and you will find the difference, and this is what the error observations. And now, you can plot these error observations and check whether there is a kind of significant pattern or not. But actually in the heteroscedasticity process we like to find out the error variance. So, what will you do? You square the error terms, and then you connect this error terms with the any of independent variables. Here the independent variable is income. So, that means out of several methods which you have already highlighted here, one particular method can be applied to check the heteroscedasticity. So, that means technically, so what will you do? After getting the error terms, you find out the error variance and then you check whether there is a heteroscedasticity or not. The simple structure of testing is after getting the error component. So, you can simply regress square of the error terms with any of x independent variables. So, here in the case of it is with respect to income. So, what will you do here again? So, you find out the square of the error term, then this is nothing but actually this into this. So, you will find the square of the error terms, and again what will you do? So, you again you can generate the particular series. Now, what will you do again? So, you go to the data analysis package and again choose the regression, and here the choice of the dependent variable is the square of the error terms, and that too with respect to any one independent variable or series of independent variables. So, you can connect with this one and this ones, and then you put OK, and you will find again a regression output and check whether it is statistically significant or not. In fact, in this case your variable is not actually coming statistically significant. So, that means it indicates that heteroscedasticity is not so serious problem, but still the model is not actually good fit, good fit if you go to this particular original output, that is this the original output, this one, and here R square is coming 32%, and so that means technically it may not have actually heteroscedasticity problem, it may have a autocorrelation problem. So, technically what will you do? So, this is what actually check process. So, every time you have to find out and check the particular process and see whether there is a heteroscedasticity or not, but in this case it is not actually showing heteroscedasticity, but this is what the check process through which you have to check and finally conclude whether there is a heteroscedasticity or not. So, that means technically so the diagnostics issues are like this. So, at a stage we like to check multicollinearity problems if there is more number of independent variables, and then you have to go through autocorrelation check, and then we have to go through heteroscedasticity check. So, that means technically these are all virus in the system, and until unless you check all these details, and you cannot use this particular model for the kind of predictions and the kind of management requirement. So, every times you have to see the degree of multicollinearity in the estimated model, degree of autocorrelations, and the kind of heteroscedasticity. So, finally, you have to use the model for the prediction which is somehow free from multicollinearity issue, even if it is not coming to 0, but somehow it may have actually very low presence of low multicollinearity, and it may have the range of autocorrelation between 1.5 to 2.5, and it should also should not have actually so much heteroscedasticity issue. So, that means error variance should be actually come into the kind of homogeneous structure. So, in the first instance when you will do this kind of modeling, you may not get the result as per the particular requirement, but over the time what will you do? So, you have to do the kind of continuous search process by changing the kind of modeling structures, by including one after another variables or dropping one after another variable, increase the sample size, decrease the sample size, change the functional form, go for the data transformation structure. Means there are various alternatives are there or options are there. So, what is actually the best requirement is every times you have to get the first hand output, and that is the best model, and then you have to continuously check one after another items, and then you have to declare that the model is free from all these obstacles, starting with multicollinearity, autocorrelation, and heteroscedasticity. Once the model is actually free from all these errors, then you will finally use this model for prediction and the kind of management decision. Otherwise, this particular model cannot give the better prediction and better managerial decision. So, the right choice is to go the kind of standard procedure, and then you find out the best models which is actually need for the particular business predictions and the kind of management requirement. So, with this we will stop here. Thank you very much. Have a nice day.